Welcome back to the workshop, and welcome to this ongoing series to make some small improvements to this drill press. So if you watched the last video, you'll know I was having trouble with backlash. There was about 0.5 millimeter of backlash, giving a small error in the knee position. So I stripped it down, and what we need to do is to take that out of there. And unfortunately it's a press fit in there, so we'll have to come up with a way of removing that. Machine up a longer one that's got a thread on the end, and then machine up a bearing cap that goes on the end that you can kind of tighten the whole thing. And then ultimately put these little thrust washers either side. Now there was already one at the top, but I didn't have space for one at the bottom, so we'll have one top and bottom. We'll have the radial bearings, and hopefully that'll be a nice tight drive unit. But before we get onto that, I want to talk about this. So these are the 3D printed parts that go over the motor, so they cover up the motor bit here and then across the belt assembly, and I've had quite a few goes at getting it just right, just how I wanted it. So this is the first one I made that went over the motor itself, so it went sort of that way like that, and I mismeasured some dimensions and this was too short, so I made the second one where that was a lot longer there, and that one fitted really well. The only thing I didn't like about that was around this joint here where it just butted up against the top cover. You know, if it just fits where it touched really, you know, if there's nothing really to locate this. So I've printed a third one, which is here, and this one's now got this little, you see a little rib on there, and then there's the counterpart on the other side there, so that's two kind of locked together and it holds that gap nice and tight. Unfortunately in the CAD I did draw it all the way to the end and then realised that wasn't, so it was easy to print on the bed like that. Realised that wasn't going to fit, so I had to kind of cut and file that away, but you know, that's going to function okay. So I'm very happy with that. Now we've got the main units over here. So this was the first one I 3D printed, and generally it looked okay. There's a nice bed finish, nice finish on the sides, clips here, and then little sort of platforms here for it to sit down on, and it goes over the top and it rests on a series of those. Yeah, nice cut out there for the pulley. Unfortunately it did peel away from the bed, so you can probably see like that should be flat like that, so it peeled away in that corner and in that corner there. Now when this is on the bed, there's about 10 mil to the edge here and here, so it only just fits on, and it was always those two at the edges, and I tried lots of different things, I couldn't really get that to work. I even tried, so you can see a failed attempt, adding some ribs in here to try and give it some stiffness, but to be honest that was probably pulling even more. I had some little slots in the sides to stop it even having, you know, pulling on the sides here, but it didn't even get that far, to be honest. This is it pulling off the bed, and that, again, that top and bottom corner, and you can see then it starts to mess up, so it's already pulling away even when it's like that. You just can't get enough brim on the edges. Well, I couldn't get anything to work. I tried quite a few, so those two weren't any good. So we come to this one. Now the obvious thing you can see there is it's in two colours. I had a look at how much was left on the spool and it said just over 100 grams, and in the software it said 106 grams was needed, and I thought, well, I'm just going to make it, and it was just on the last few strands, and yeah, didn't quite make it. So I wasn't sure how it was going to react. First time I've run out of filament, so I just pushed some more green in through the AMS and pushed it all the way in until it felt like it was grabbing on the motor or whatever, but it still realised it was out, and it pulled all the black through, and it paused, pulled the green through, and then it carried on as if nothing happened. So I guess you don't need to panic if it runs out, you just push a new one through the AMS and it will sort itself out. But I went for green in the end because it's a similar colour to the rest of the drill, and yeah, maybe the little green trim will look okay. Anyway, the new features here, I just did the pressure on that, so it's a slightly different shape, and the main one is, you can see, it's in two pieces. So what I ended up doing is putting a male and female dovetail in here, sliding dovetail, a little ridge to push up against, that's on both sides. So this kind of slides into that, and that looks really good. And because you're only printing two small bits, no problem at all. Straight off, you know, first print, no problem. And then the other thing I did was at this end, very hard to see, but there's a little relief in there, and that goes. So that little feature goes into there. because of the angle of these clips and the ones at the back, it's always trying to pull down like that, or pull it backward, so it's always trying to pull that joint nice and tight. So yeah, obviously it all clips into place once it's on. And I did try it before I stripped it down, it looks really nice. But before we get onto that, we've got to obviously sort out the drive mechanism. Oh yeah, one more thing in terms of the actual here. Rather than waste, well, I think about 4 hours in total to print both parts, I thought I'd just trial a little dovetail, and I gave it like 0.05 clearance and 0.2 clearance at the end. Wasn't quite sure, and that's a nice ratcheting fit, and I was just about able to push that down. So I've done myself a little drawing so that I know, these kind of dimensions with these clearances give you that nice fit. So if I ever want a dovetail in the future, I've got a reference drawing to go back to and a little reference part. So yeah, pleased with that in the end. It's a bit of a shame to have a joint, but rather that and have nice clean parts. And yep, pleased with that. Right, let's go over to the machining. And the last video I did show that ring there, I thought I'd already made one, but problem is I've got to put an M39 thread in there, and this is obviously to be a slide fit over there, it's got to be 40, and in fact it's just a tiny bit over, just to give it some clearance. Oh yeah, 40.05, whatever. So you're not going to machine an M39 thread into that, because obviously it was designed to just go over there and then tighten on there, but as I said before, this is nowhere near long enough. Right, so we need to make a new one of those. No big deal, but that's what we've got to do. So we need to strip this down a little bit more, and somehow, I don't think I'm going to be able to somehow grab that and pull that out again. It was a pretty tight fit, so I'm probably going to have to turn it down in the lathe. The problem I got is how to hold this on these teeth. So I've come up with a bit of an idea. It's a bit risky, never done it before, but I can't really see a way through. So I'll get this off and I'll show it to you, and you can tell me afterwards if you think it was a good idea or not. Right, so we're going to get that, you can just about see the line out of there. Yeah, so I might give it a go, just see if I can find some way of pulling that out of there, but I don't think I'm going to get it out. So what I've come up with is this idea. So I've 3D printed this part, it's got all the holes on, I've got 3 flats on it, and we can bolt that somewhere onto there, hold it in the drawers on the chuck on the lathe, and then they'll butt up against the ring there, so that'll hold it square, and lightly part this off and then come in with a boring bar and just take it really close, and then when it's really close kind of pull it out with pliers, something like that, so I don't go into the bore itself. Now when I 3D printed this, it took a bit longer. I did 5 layers each, so it's pretty thick, and there's actually layers that join all the way into here, so next to the jaws you've always got a hole, and it's spreading all that stress out, so everything's super thick. It feels like if I take some light cuts maybe it will work. Worst that'll happen is it snaps and this flies off, so we'll be standing well clear of that. Wish me luck. just clean up that edge and then just put some sandpaper around there. You can still see there's obviously marks in there. I was trying to get it out, and probably from the press fit originally as well, but it does feel quite smooth. It'll help with the press fit anyway, with a little bit of roughness, and it should still be 40. Yeah, pretty much just not ideal with calipers, but yeah, it's around 40 there. Okay. Alright, let's get this off. It's done its job, and decide which one I'm going to do next. Probably, I think, the tube that will fit in here. Okay, so I'm taking advantage of the fact this piece has got these bits sticking out, so I can hold on to it, kind of like its own mandrel. We'll turn this is currently about 60, we'll turn this down close to 40. 40's got to be the press fit, so we'll creep up on that and make sure we get that dimension hit. We probably want to be 40.05 or something like that. And then we can machine a little bit in here, which is our M39 thread, so we'll machine that down to the correct size, put the relief in, and I think, yeah, we'll probably put the thread in here, then we'll take the whole thing out, take the bandsaw, cut that off, bring it back, hold it on this outer dimension and skim that off, and then drill the clearance down the middle. It's only clearance for the ball screw, so that's not critical. It doesn't have to be super concentric with this, but I want all the dimensions that are on this side to be machined in the same setup. So let's get going. Okay, so we should be at 40.65. I'm shooting for 40.15 because this is really hot, and then when it's cold it'll probably be 40.08, 09, somewhere around there, and that'll be a nice press fit on the pulley. Once I've determined that's okay, then we'll turn the main part down to 40, so it's a nice fit in the bearings. But at this end where the pulley goes on, I need it to be an interference fit on 40mm, and here I need it to be a nice transition fit, or actually a hand fit through there, and then the threads this end, so we've got to do it in stages. Right, so let's just check where we're at. We're going for 40.65, going down your 0.5mm steps. Alright, got lucky on that one. Let's try a few in case it's tapered. 6.4. Okay, 6.5, 6.6. 6.4. Okay. Okay, I've just turned down the thread there and put a relief in it, and this range is 38.96 to 38.7. Okay, I just brought this in with a little bit of emery because I want to be able to manually assemble the bearings onto here, and you can see it's a pretty good fit. So there'll be two bearings there, radial ones, and okay, looking good. Alright, now we need to cut that thread, so that's M39 by 1.5. We'll set this up in threading mode on here. This is the electronic lead screw. You might remember this project a few videos back. and I was just confirming. Okay, so in feed mode there, we need to go into thread mode, and this is the pitch. We're in metric. Yep. I want 1.5. Okay, we'll turn the speed right down. We'll do a scratch past there. It's barely touching, so it might not leave a witness mark. And yeah, I think that's it. We'll set on there. Let's check that. Yep, 1.5. Well, something happened there. I ended up abandoning cutting that thread. As you can see, I've just turned it back down to plain shaft again, and we'll have to go a little bit smaller. So I was about halfway through, and suddenly the form of it just changed a bit. It looked a bit different. And I thought, well, I'll just carry on anyway, going to my numbers. And yeah, I didn't miss any steps in terms of engaging at the right point. It was still tracking correctly in terms of pitch, so I don't really know what was going on. I have had a look at the cutter, and it's that one there. Hard to say. It looks like it might have lost that edge, which is why it didn't really form properly if you compare that to an unused edge. There, it's just there, yeah. So maybe it's chipped, I'm not sure. I mean, these are low quality eBay specials. I have chipped this one already. I broke that a while back. So, you know, maybe it's time to put a fresh cutter on. Also, just to be sure I wasn't getting any tracking issues in terms of, because I've got an electronic lead screw on this machine, just make sure there weren't any glitches there. I've plugged the DRO and the electronic lead screw into a completely remote power supply over the other side of the workshop, so hopefully a little bit of noise suppression on that. So I'll turn this down until it's just at the major for a M36 thread rather than M39, which I was originally going for. Yeah, I've had to skim it back down again, and then we'll start again, and that'll still be fine, but this is going to be my last chance. If I need to skim this one down, there won't be enough left by the time I put the bore through, and this will be ruined. So right, let's give that a go. Interesting. So I've just put a fresh cutter on there. I'd already turned this down to the correct size, so we've got our major diameter there, and I thought I'd just do a fresh air cut right back here and just confirm that on the thread dial, you know, it was a positive engagement, the window of engagement was working correctly, so when I was engaging at 1 in this case, it was always going to be the same. And I found something interesting which may have not been helping. Right, so the cutter's well clear of the work, and we'll just start it on the lowest speed, which is there. It's going round. Actually, before I engage it, I can show you. I was just checking, I wonder if there's any backlash. I mean, no, it's not as bad there. It's kind of, yeah. So I think we'll get that nicely engaged before we go any further. Right, I was just trying to tighten it, and I think I found another problem. It's probably been like that since day one, because I've never bumped it or bashed it, and there's no evidence it's been hit. But essentially, so this is the thread dial indicator. Oh, and yeah, there's a spacer on the end there. So there's a gear on the end there that picks up on the lead screw, so when that goes round it drives that, and that turns the little dial at the top, and you either wait for whichever mark you're on, you know, the same one again, or depending on the pitch, different ones apply. Anyway, Main thing is that bolt is pretty straight, and there is a spacer which I guess they've added because they've probably added this bracket and cover, and then it hits that bolt head, so they put the spacer on to bring it out. Trouble is that hole there, it's an M5 hole, is tapped a bit of an angle. I don't know if that's shown up on camera, but it should be over here. It should be about there like that, and it's actually more like that. So it means this comes in at a funny angle on there, and it's not really engaging. So I mean, it's hanging on, and I have used it for a while, well, for the many years I've had the machine, but obviously it's just clinging on in there, and now I really want to use it again. I don't know if it's going to work. Oh, so what project was I working on again? I've gone off at a tangent. So if I get that engaged on there, tighten that up. I don't know if you can see on camera, but that's way out of line, or it might pull itself in, but I think it's going to try and pull it in, but then when I advance, so engaging, I'm just hand turning the chuck. Right, I think I'm going to have to come up with a better idea from that, because it was clearly just hanging on, and now it doesn't really want to engage, and it keeps skipping past. And where this wants to be is sort of nice and square like that, and that's, yeah, so if I turn this, nice engagement, yeah, it doesn't skip, but where it sits now, it's kind of like that, and it's, yeah, it's barely hanging on. So oh, I think that's and the nuts come loose. Anything else? Alright, so we'll do it old school. We'll keep the half nut engaged, and we'll just go forwards and backwards, you know, stop the chuck, come out, back, so it'll definitely not lose engagement. Just got to be quick on the stop button so I don't run into the end of the part. Alright, let's try that. That should be it. Okay, so I've taken out the chuck and just cropped off that spare end there in the bandsaw. And what we'll do now, I think we'll hold it this way, trim that back so we don't need that bit till it's flush, neaten up all these edges, turn it back round and trim this down to the final length, and then we'll bore it out to 28.1. Okay, we've bored this out to 25mm. I've just turned it round because I've got a better hold of the part this way round. So we need to take this from 25 to 28.1. It's only clearance for the ball nut to go down, so it's not critical. And as you can see, with that stick out there on the boring bar, this is probably going to chatter and make quite a lot of noise. So if it does, I'll just play some nice soothing music over the top so you don't have to suffer. Meanwhile, I'll go and get my ear defenders. Right, so there's our finished part. Got the thread there in the end. Needs a little bit of a clean up. I'll fire up the air compressor later and clean it all out, but for now we need to see if it's going to fit. So this end needs to be a gentle fit over the bearings, and this one is a little bit larger for a press fit into the pulley. So this is one of those bearings there. It's one of the radial ones like that, and so this end should be a nice easy fit, which it is. I don't want to go too far, I might get stuck, but that's okay. So that was basically spot on 40mm for the 40mm onto there, and then that should be 40.05, just the last 10mm to get a press fit in there. Alright, doesn't want to go in, so it's just on the edge of being a press fit, so great. So I just want to double triple check there's nothing else I need to do, because once I press that on there it's a bit awkward to hold it. I think we're okay. Oh, I better make sure, does the ball nut fit down there? Ooh. Yeah, maybe I could have given it another 0.1 clearance. Looking good. Okay, we're on the last pass now. This is the major diameter we need to hit for this thread. We'll do this pass and then see what the fit's like and then take it from there. Thinking about it. Alright. Just open up a little bit more. Okay, I've just done one more pass with about another 0.05. Getting close now. It's a 1mm pitch, it's quite fine, so I'll make sure I don't cross thread it. Also, aluminium on aluminium likes to gall up and you get it stuck. Yeah, maybe a spring pass. Just make sure it goes all the way to the end. Obviously we're going to cut this off, and I've just threaded all the way through for now. Just so I didn't go into you know, basically a blind end each time as I got deeper. Is it going to go all the way home? Yes. Probably needs a slight chamfer on the edge of that thread. Right. Pleased with that. Always a bit nerve-wracking making two threads that's got to fit together. And in terms of clearance, that's nice. Alright, let's clean this up and have a look at what we're going to do next. Right, so we've got the part in the vise, I've trammed that in and we've just picked up off the centre of that. And what I've decided to do, because there's limited room to swing a wrench around when you're underneath the machine, when you're trying to tighten this nut, you only probably got about 15-20 degrees of sweep before you hit one of the posts. So I'll put 8 holes all the way around at a 45 degrees between each one, and that will give me some chance of getting the pin spanner in there at some kind of angle. So let's put the cutting bit in and we'll machine out each of these. Now there's probably some kind of hole pattern generator over on the CNC machine, but I thought the quickest thing to do is actually just use my drill press here and use DRO. I've just typed in radius, 8 holes, and then the total angle, and we've got all our XY coordinates for those holes. So we've got 1, 2, all the way up to 8. And then I've just made a note of those XY positions, and we can just type those into the MDI and machine them out on the CNC machine. So after that, I took the part out of the CNC machine, put it in the lathe and removed all that excess stock on one side, put some chamfers on it. And then drilled and tapped a hole to put the grub screw in. And then the nut was finished. Okay, so it is all finished up, tapped. So in the end I put extra holes around, I made it thicker and decided to go up to M8 for the grub screw rather than M5. It should save a bit on the threads and in terms of sort of wear and tear and whatever. Right, so I think it's time to put this together. The other thing I did is just turned up this little brass part here, so that will drop down into the threads like that, hopefully, yeah. And then that will bear against the aluminium threads on the main spindle there. And then we'll put the grub screw in the back. Alright, so I think it's about time we put this together and see if it's going to work. Okay, so I think the thing we'll do first is put the main thrust bearings on. Yeah, those in there. And then drop that through the housing. I haven't tried this, hopefully it does actually go. Okay, we get our thrust bearing ready. And if we can use this to pull it home. Okay, I think we got it. Okay, so I think we just need to get that so it feels okay. Okay, drop our little rasp bit in. Alright, it's only aluminium, so it is still soft. Steel would have been better, but here we are. I think it would have damaged the threads putting the grub screw directly on. Okay. Actually, what I might do, just leave these a bit loose, get it powered up and move it up and down, and it will find its own position, I think. Alright, let's get it wired in. Okay, I'll switch it on. Wood. Oh. Okay, so I think what's happened is you can actually see the sleeve there, or the inner shaft there, is pulled out of the press fit in the pulley at the top, and it's driven the whole assembly down. So whether the ball screw has hit something inside here, hasn't quite, because I haven't fully aligned it, maybe it hasn't quite gone into the hole properly, but I need to strip it all down, take that press fit apart, although it's probably already almost come apart. Maybe put a little machine a little groove around it, get some permanent Loctite in there, get that nice and tight. Maybe open out this hole in this base and the base down here, just make sure it definitely can't hit. We'll do all that, put it back together, and we'll bring you back when that's done. Yeah, there it is apart again, and yeah, it's pulled the shaft partially out there, so we'll sort that out, put it all back together, and use a bit of Loctite. That should sort it out. Okay, it's back together. I've definitely got it clear this time, so it moves up and down. It's nicely aligned and adjusted. I'll just make sure it works. We'll take the wood out, put the covers on. That should be it. So this time what was happening was the ball screw was getting caught on the hole in the base there, and it was stopping the motor running and stalling it out. It was just too close a fit really, so I ended up taking the whole thing apart and then using a hole saw to cut out the base and then cut a big hole into the table as well, so I had plenty of clearance. Hopefully this time it was going to work. Okay, so I took it all apart, propped it up with wood again, took all this out, drilled a big hole in the table and into the base here, and then I've put it all back together, and hopefully it won't foul on it anymore and this should work. So we'll just put the cover back on and then we'll give it some tests. Okay, let's try it out. So I've got it set to 1mm step just so we can run through the tests a bit quicker rather than 5mm. So let's give it a go. Yeah, it's pretty good. Let's go down again. Looks pretty good. Right, let's zero it and then go up again. Now we'll go up. So it was 0.5mm now. I think we've got 0.085 of backlash. About 0.1, isn't it? I suspect there's a tiny bit of free play in that axial bearing there, and that's enough just to throw it off. I'm worried about tightening it anymore because it might put too much load on the motor because we're going to be squashing those bearings. So maybe I'll just live with it. It's not too bad. I've got the DRO readout. I know where I am in absolute terms. Better have that reliable operation rather than try and clamp that up too tight, because I think I might be getting near the limit on the motor. Alright, so anyway, that's where we're at. Alright, so I think we've finally got this thing working as intended. Still haven't got a function for that third switch. I don't know what I'll do with that, but we've got the continuous and the step, and for now I think that's okay. We can move up and down pretty quick. I think it was about 7 seconds one end to the other. We've got our limits working as well, and obviously we can step. We just got that little bit of backlash, but I think I'm going to run with that for a while and just see if it annoys me or not. I've still got the readout on the DRO, so I know where I am in absolute terms. And for most of the things you do, I think that will be absolutely fine. Okay, so here we are, basically at the end of this project. It does everything I wanted. We've got our 3-phase motor on it, we've got the VFD inverter control with the custom cabinet up there. We've now got the motorized knee, so we can move that up and down. It's software controlled, so if I want to change something in the future via the Arduino software, I can do that. I've got my DRO on my X, Y and Z on the table here. Got my lights, of course, that we added recently. Got a 3D printed cover for the stepper motor and the drive system down below. Yeah, couldn't be happier. It's excellent. So what I might do, just let me know in the comments if you'd like this, because I think this is like 55, 56 episodes long, whatever. Maybe what I'll do is just one 20-minute, half-hour like director's cut of the key points in the project all the way through with a bit of narration, something like that. So let me know if you want to see like just one short one-off, especially if you're new to the channel and you don't want to go all the way back to the beginning, and I don't blame you for that. So maybe I'll edit something together. Just shows the whole thing just in the key stages. So let me know if you want to see that, and I'll see what I can do. One more thing, I ordered I think 4 filaments for the 3D printer. One of those was PETG, so I can replace the brackets in there that are currently PLA, just so we don't get them creeping down as they warm up, start to distort, especially on those main power supplies. So I won't video it, but at some point I'll replace those with the PETG material, so I should give those a little bit more stability. Right, well, I can't believe we've come to the end. I've finally got everything I want all working as intended on this drill press project. It's been a long journey, but I've really enjoyed it. So look out for this being used in future projects and some of the new functionality as well. Thank you for all those who've been following from the beginning, anyone's joined in the middle, or anyone's joined at any point, and especially if you've given me a comment. It's been really helpful to kind of guide this project. It's useful for learning from other people, and hopefully I can feedback as well, and we complete that nice virtuous circle. Okay, so all that remains to be said is thank you very much for watching, If you want to see what the next project is, feel free to click that bell so you get notification. If you're not a subscriber and you like this kind of thing, feel free to subscribe. And with that being said, thank you very much for watching, and see you next time. Can you mill with it? No, you cannot mill with it. This is a drilling machine, not a milling machine.